book, it entails a little extra analysis. If you recall on page 228, we had number 5. We had to do A, B, C, D, E, F, and G. I'm going to do 5G. I think that was probably the most complex. So if you can see how that's done, then all the others will be a piece of cake. Okay, so the question is, determine the number of moles of the given element within the given molecular requirement. And so in the case of 5G, they're asking you for the number of oxygen atoms. Okay, and they gave us a molecule Mg3PO4 2. And the first thing you have to do, since they want you to find out how much oxygen you have, is to split out the oxygen from this molecule. First step, find out how many atoms of oxygen are in that single molecule. So one molecule of this magnesium phosphate is the O4 times the 2. Don't forget the 2. That's going to be 8 atoms of oxygen. So if I have 4.999 times 10 to the 25th units of this molecule, I'm going to have 8 times that number of oxygen atoms. So I just take the 8 atoms of oxygen and multiply it by the number of particles that are in, or the number of molecules that are in this group, and I end up with 39.992 times 10 to the 25th oxygen atoms. So now I have a number of particles, and this wants me to find out how many moles does that make, or how many moles does the atoms make up, okay? So I simply start my new question. How many moles of oxygen atoms is 39.992 times 10 to the 25th oxygen atoms? That's the quantity of particles that I have. So I write that down first of all. I'm going to write down 39.992 times 10 to the 25th times some conversion factor, which I have to figure out, okay? Since this is going to be oxygen atoms, I would like to have some particles in the bottom here with moles on the top, and that's what I did on the next step. I put in oxygen atoms. This is the number of particles, and I want to convert it to moles, so I put 1 mole has 6.022 times 10 to the 23rd oxygen atoms. And the oxygen atoms cancel, and I ended up with just this arithmetic problem, and I take the 39.992 times 10 to the 25th, and I divide it by 6.022 times 10 to the 23rd, and I come out with 6.641 times 10 squared. And if I look up here, I can see that I've got the number of significant units is going to be 4, and I want to maintain that in my final answer. So I've got 6.641 times 10 squared moles. Okay, that's like, if I moved it over, I could say I have 664 moles of oxygen atoms. Okay, that should help you do the others. Good luck.